all, how is everything? How are you, Abdul Zahir? Abdul Rahman, how are you? Inshallah ta'ala, we will continue in the binary trees for the breadth first traversal. Today we will give example of the traversal order, which is the breadth first. We will see how this technique can go. So here we need to check first the processing order which come in the coming figure. As you see, here we have tree, and the tree consists of the root which is named by A, and we have left branch and right branch. For the left we have B, then the child C and D, and from the right side we have E and F. So how the breadth first can work? Here we have the concept of walking in order. How the walking in order or the breadth first can work. At first we will visit the node A, which we called it uno. What we called the node A مين يعرف يا اخوان ايش بنسمي النود A؟ الروت. So we will start by the A root. After that I will use my red marker here, so you can follow me in this walk from the left to right. We will start from the A, then go down, then to go to the left side, then to go down. After that you will go or visit the B, then to go forward, then to visit E, then to go down, then to go to the left, then to go down, then to visit C node, after that D node, and in the final we will visit the F node. This walking is easy or difficult? Abdul Zahir, easy. So we will follow this path so we can go and to visit all the nodes. But the concept here to start from A, okay, then B, then E, after that C, B, F. So if they asking you to write the path or to write the order of the visited node, you will write A, B, E, C, D, F. Did you know how we can write this order? This technique we called it breadth first. breadth first. واضح يا اخوان؟ عرفنا كيف كتبنا ال A B E C D F. سهل ولا صعب؟ Okay. Now consider a binary tree with n node. How many recursive calls are there at the most? For each node, 2 recursive calls at most. And we have 2 by n recursive call at most. What is the n? N is the number of the nodes in our binary tree. What about the annotation? The annotation for the breadth first is O of n for any technique for the sorting of the binary tree. Okay, here we have other example that ask us to find pre-order, post-order, and in order. Already we solved such this example in the past lecture, so no need to re-explain it. This is other example. Yes, now we will start for a new topic. Here we have the binary search tree topic. Okay, the K property, we have the value at the node. We need to check which is smaller to be in the left, which is larger value, which should be in the right subtree. Example, if we have as this figure x, y, z, we need to check x if it is greater than y, and again to check x if it is less than z. So here we need to check x if it is greater than y, and if x is less than the z. Okay, so here the smaller will be on the left and the larger will be on the right. Here we have examples. We have on the left side 10 on the root, then on the left we have 5, on the right we have 30. For the 5 we have in the left 2, and for 30 we have in the left 25, and on the right side we have 45. Okay, this binary search tree, but for the example on the right side we have 10, then 5, 45, 2, and 25, and 30. This is not a binary search tree. We will see why this binary and why the other is not binary search tree. If we compare between this one and this one, what is the difference? Just between the 30 and the 45, and here we have different order. We have the 45 come at first, then the child come at the last, because it come in the right side. So it is not binary search tree. Now in this binary search tree we need to try to analyze the pre-order traversal sequence. It is F, B, A, D, C, E, G, I, H. How this come? Who can assist on this analyzing the binary search tree؟ مين معنا؟ مين يقدر يساعدنا في هذا الموضوع؟ عبد الزهير، عبد الرحمن، مريم. أيوة. We should start at the root. So the root here is F. Okay, then we will go with the left side. From the left side we have B. After that, the B, it has left child, so we will visit A. After that we will come back to B. B already visited. Then we will go to the D. Okay, after we visit the D, then we will go to the left side, which is C. After that we will come back to the D. D already visited. Then we will select E. After that we will come back to the F. F already visited. Then no choice to visit G. Okay, after G, no left side, so we will go to the right side, which is I. This is I. After that, no choice else to use H. This is the H. So by this technique we can implement the pre-order traverse sequence. سهل ولا صعب؟ The in order, you should come back to the last lecture. So we already explained how we can go in order and how we can go for the post order. This exercise for you, so you can train yourself how you can calculate them and how you can find them. Okay. Now we will try to explain how we can go with the insertion operation, or how we can insert a node for a binary search tree. What is the BST? Means the binary search, okay, tree. Okay, so we need to insert the new node, which is 20. We need to insert a new node, which is 20. How we can insert it through this BST? At first, we need to check the root. The root here, what is the value of the root? It is 10. So 10 is less than 20 or greater than 20? No. The 20 is greater, صح؟ أيوة. 20 is greater. So when the 20 is greater, we will go for the left or the right. We will go by the right. We will go by the right side. Then I am here, okay? Then I will check again between 30 and 20. I need to see who is greater and who is smaller. Okay, so here I have 20. The 20 is greater than 30 or less than 30. Sure, the 20 is less. So if 20 is less, then I will go to the left side. Agree? Agree ولا مش agree? Okay. Then after that we need to check. Now I am on the 25. Again, I will do comparison between 20 and 25. Who is less? Sure, 20 is less. So it should be on the left direction. So I can insert it to be here. Now I can answer you why I put the 20 here. Through the analyzing for this value between all the values that came in my BST. And maybe some of us will ask why the 20 come here, not here, not here, not here, not here, not here. So all of these will be the incorrect solution, but the correct solution, it will be here. Is it clear for you ولا مش clear؟ واضح ولا مش واضح؟ واضح ولا ليش عبد الزهير؟ ليش 70%؟ ليه 70%؟ No. We must come back and start again to increase the percent to be 100 instead of 70. We need to raise it to become 100. Okay ولا مش okay؟ طيب focus with me. طيب إبراهيم عبد الرحمن it's okay. Ibrahim is okay, no problem, because of Abdul Zahir want me to re-explain it. No problem. Here I will consider Abdul Zahir, please consider the value which will we insert it. We need to insert how much? 20. Right? طيب. Then we need to compare it at first for the 10. It will be here. We need to agree before we can go on. For what we need to agree? To agree for this concept. If the value which is 20 is less than the root, then we will go on the left. If it is greater, we will go to the right. So this is the answer why we went here. Did you understand why? Why we put 30 in red color? Because the 20 is greater than 10. So we should go to the right side. Now we are set on the 30. The same thing, we need to compare between 20 and 30. Again, if this value is greater than 30, then I will go where? To the right. If it is less, I will go to the left. So here you should tell me, I will go to the right or to the left? Yes, it is less. Then I will go to the right or the left? Sure, it will be on the left. So this is the answer why the 25 in red color. Why I am sitting now on the 25. My finger now where it's pointed is at 25. Again, I will compare between 20 and 25. Because 20 is less than 25, that means I will go to the left side. Did you note the 20 point where it is now? It is on the left side. It's okay or still? Okay. طيب. The remove operation, it will be the same as the addition, but we need to explain this through this example so we can see how the implementation will be happened. Now we need to delete 25. We need to delete 25. 25 already it is here. صح ولا لا؟ فين موجودة؟ موجودة صح؟ طيب. Now after طبعا the 25 through my site I can see it is here, but through the algorithm I am not sure where it is, so I need to find it at first. The same thing, I will compare between 25 and 10. Because 25 is greater than 10, so I will go through the right side. Then I will sit here. Now, I will compare between 25 and 30. The 25 is less than 30, so I should go to the left side. Then I will compare between 25 and 25, so I found it. It is here. Right? I found it at first. After that, I will try to remove it or to delete it. I need to delete it. I will delete it through the command of deletion. Okay? Easily, nothing will be happened. So the new shape of my PST, it will be as this one. Nothing changes. No change. All the nodes will be the same. But try to follow me through this new example. We need to do the deletion of internal node. Here we need to delete the 10. The 10 here, it is the same value of the root. So we need to remove the root. What will happen? What will happen if we delete the root? We will try to find other point to be the root. How this can be happened? As the following. Now the 10 is greater than 5. So we need to find the less value. So it is 5 here. Okay? The 5, it will be raised to be the root. This is the O. And after raising 5 to be the root, sure the node number 2, it will be placed instead of 5. So it will be raised up. 2 هتحل محل الخمسة. بما انه الخمسة حلت محل العشرة، ايضا الاثنين هتحل محل الخمسة اجباري. تمام؟ سهلة ولا صعبة هذه؟ كلير ولا مش كلير؟ طيب. Here we have other example. Check with me please. We need to delete 10. Okay? طيب. After the 10 to be deleted, we need to check to replacing the 10 with the smallest value in the right subtree. Where is the smallest value on the right subtree, it is here, it is 25. This is the right side. Where is the smallest value? It is 25. So 25, it will be up, then to go to the up. So it will be the first node. 25, it will be the first node regarding to the right side. Right. We know the root of the tree, the count keep track of the number of nodes, how we will represent a node by a binary tree. Here we have a binary tree node, which is the node of the linked lists. Here we have left child and right child and the root. So the element, it has a reference to the data, a left reference to the left child, and the right reference to the right child of the node. This is the all of our topic. Now we will go to week 12 and 13, which is the last topic of our material. Right, now we will move to the graph. In the graphs we have two types, which is undirected graph and the other type which is directed graph. In the graph we have depth first and breadth first, same as the BST. Nodes and links between them may be linked in any pattern, unlike a tree. Here we have something which is called vertex, which is a node in the graph. In the binary tree or in the tree we called it, the elements we call them nodes. But now in the graph we call them vertex. Vertex. The connection between those vertex we will call them edges. So here we have edges and vertex, such as this graph. Here we have undirected graph which has how much vertex? Here we have 1, 2, 3, 4, 5 vertex. Okay, and we have links between those vertices. which we call them edges. So what are the components of any graph? The answer is vertices and edges. What are the names of those vertices? They have those names: V0, V1, V2, V3, and V4. What are the names of the edges? We have E0, E1, E2, E3, and E4, and E5. This is the label of those edges. طيب. Now for this graph we have undirected graph. Why it is undirected? Because no direction, no arrows between any two vertices. We have no direction. Okay, the graph G consists of set of vertices V and set of edges E, where each edge is associated with a pair of vertices. So any link or any edge can be located between any pair of vertices. We write G equal V and E. Then G, it will be pairs of those vertices. We have at first the set 1, 2, 3, 4, 5, 6 vertices, and we have 1, 2, 1, 5, 2, 3, 2, 5, 3, 4, and 4, 5, and 4, 6. Okay, those are the sets of the components of the G graph. The labeled symbol graph, vertex set V. What are the vertex? V1, V2, V3, V4, 5, and 6 vertices. What about the edge set? The edge set, any link or any edge that can locate it between any pair of vertices. So here I have a set of edges: 1, 2, 1, 5, 2, 3, 2, 5, 3, 4, 4, 5, and 4, 6 edges. Here we have some specific type of the graphs. For example here A. I will use my marker. Okay, here for the A we have connected graph. Why? Because all the nodes are connected with each other, so we called it connected. We are called it connected, and there is a simple path from A to B. Okay, what about B? B, we have completed graph. Why? Because each node is connected for each other node. كل نود أو كل فيرتكس موصلة مع الفيرتكس الآخرين. تمام؟ كل فيرتكس موصلة مع كل الفيرتكس الآخرين. Also we have third type, which is disconnected. Why disconnected? Because I have found a vertex which is not connected. Okay, we have a vertex which is not connected. A directed graph as this one. We have row head between any two vertex. We have a row head. So here we have arrows are used to represent the edges. Arrows start at the source vertex and pointed to the target vertex. إذا عندي source vertex وعندي target vertex. تمام؟ فين السورس فيرتكس؟ هذا. فين التارجت فيرتكس؟ هنا. تمام؟ فين السورس؟ هنا. فين التارجت؟ هنا. إذا السهم دائما point to the target. Point to the target. It go from the source and point to the target. We called it tic-tac-toe. this example modeling state in a chess game which is tic-tac-toe. طيب here we have a directed graph. We have two sets. Okay, what they are two sets, V and E. What are the labeled of the V اللي هم الفيرتكس او الفيرتيسيسز. مين هم الفيرتيسيسز في هذا الجراف؟ بسميهم باساميهم 2 3 5 7 8 9 10 11. What about the edges set؟ مين هي مجموعة الإدج؟ مين مجموعة الإدج؟ بسميهم بأزواج مرتبة من السورس إلى الديستنيشن، يعني 3 to 8 3 to 10 5 to 11 7 to 8 7 to 11 8 9 11 2 11 9 11 10 and so on. كلير ولا مش كلير؟ كلير ولا مش كلير؟ طيب directed graph representing a portion of a city's street map. نفترض يا سيدي العزيز انه here we have a district، انه في عندنا حارة، تمام؟ هذا السكوير او هذه الحارة، شوف يا سيدي العزيز، وكأنه الرسمة اللي امامي represent a roads or a directed roads. كيف؟ مثلا عندي هذا طريق في اتجاه واحد، مش في طرق احيانا ذات اتجاه واحد، صح ولا لا؟ هذا طريق في اتجاه العكس، هذا الطريق في اتجاه واحد، هذا الطريق صاعد، مش انتوا في المدينة بتقولوا صاعد ونازل؟ هذا الطريق الصاعد، صح؟ وهذا الطريق الايه؟ النازل. مين يعطيني مثال على طريق صاعد وطريق نازل؟ يا اخوان الطلاب اللي بالمدينة، الناس اللي بالمدينة، طريق الهجرة صاعد، طريق الهجرة نازل، ولا طريق ايش اسميها؟ ايش اسماء الطرق في المدينة؟ طريق قباء النازل وقباء الصاعد، صح؟ ولا انا غلطان؟ الشارع ايش؟ الحزام؟ لا في طريق مشهور كثير هناك اعتقد انه قباء الصاعد وقباء النازل، اعتقد اذا ما كنتش يعني مخطئ. المهم انهم في المدينة يعني يمكن هي الدولة الوحيدة في البلد الوحيدة في العالم اللي بتلاقيها ايش؟ بتلاقي فيها طريق صاعد وطريق نازل. فهم عرفوا الحكاية وقاموا ايه؟ عملوا لها دايركتد جراف هنا. تمام؟ في بعض الطرق بتلاقيها صاعدة يعني طالع في اتجاه شمال، وطرق ايه؟ نازلة في اتجاه الجنوب وهكذا. المهم وفي عندي بعض الطرق in two direction، في اتجاهين اثنين، تلاقيه طالع نازل، صح؟ طالع نازل in two direction، in two direction by direction. طيب في عندي هنا بعض الترمينولوجي بدنا نتعرف عليها في الجراف. اللوبس edges that connect a vertex to itself. لما يكون في عندك vertex وعندي edge بيطلع من اللوب وبيدخل فيها كمان مرة بنسميها ايه؟ لوب. عندي path sequence of vertices P0 P1 Pm such that each adjacent pair or vertices are connected by edge. لما يكون في عندي two vertices adjacent، okay, the link between them called path. Also we have a cycle. What is a cycle? A path of length greater than 1 that begins and terminates in the same vertex. لما يبتدي من فيرتكس ويرجع الى هذه الفيرتكس بنسميه سايكل. A connected graph T without any cycle is called tree graph or free tree or tree. When a simple directed graph does not contain any cycle, it is acyclic. It is acyclic. What is acyclic? That has no or does not have contain any cycle. No cycle. Parallel edge, more than one edge connects two vertices. إذا كان في عندي أكثر من edge بيوصلوا إلى نفس الفيرتكس, so we call them parallel edges. Simple graph had no loops and no multiple parallel edges. Path. Here, for example, what is the path? A path of length n from vertex 0 to vertex n is the alternating sequence of n plus 1 vertices and n edges, beginning with the vertex b0 and ending with the vertex b, which is incident upper. Connected graph is one where any pair of vertices in the graph is connected by at least one path. Adjacency matrix is a query grid of Boolean values. If the graph contains n vertices, then the grid contains n rows and n columns. For two vertices numbered I and j. Undirected graph, the element at row I and column G is true. If there is a link between I and j, we called it or we named it true by 1. And the element of row j and column I is true. Directed graph, elements that row I and column j is true if there is an edge from I to j, otherwise it is false. Here example for the graph. Adjacency. If there is a link or edge between A and B, vertex A is adjacent to vertex B and B is adjacent to A. لما يكون في عندي edge بين ال A وال B, ايش بنسميهم؟ adjacent vertex. ولو قلنا A adjacent to B ولا B adjacent to A نفس الشيء. ليش؟ لأنه undirected. لكن إذا كان عندي هنا directed هقول له ايش؟ vertex A is adjacent to B but not B is adjacent to A. يعني هأسمي التارجت، هأبتدي بالتارجت بعدين السورس. vertex A is adjacent to vertex B. Here we have undirected graph. عندنا مثال على ال undirected graph. بدنا نملي هذه الماتريكس، هنسميها من هنا طالع adjacency matrix. اسمها ايه؟ adjacency matrix. ممكن يجيب لك سؤال في امتحان يقول لك fill in the adjacency matrix of this undirected graph. بسهولة هروح اشوف فين في edge عندي بين. طبعا هنا هاسمي الرو 0 1 2 3 4. منين جبت هذه الاسماء؟ من هنا 0 1 2 3 4 وبعدين الكولومز the same name 0 1 2 3 4. agree? After that we need to check there is edge between 0 and 2, so we need see where is the intersection between 0 and 2. Here is the 0 and here there is the column 2, so the intersection is true. clear ولا مش clear؟ طيب the same thing I will go here from 2 to 0, so I will fill here true. clear ولا مش clear؟ كلير ولا مش كلير؟ the others are the same. هشوف فين الانترسكشن وفين it by true. True means there is edge. True means there edge. True means there is an edge. Edge. Okay. can be implemented with two-dimensional array. ممكن ننفذ هذا بالكلام Boolean two-dimensional array adjust matrix. Adjust matrix equal new Boolean 5 by 5. هنا graph can be also represented by creating an adjacency list, not array. No, it will be list. فهنا هعمل له 0 1 2 3 4 until 6 such as here 1 2 3 4 5 6. بشوف ايش اسماء الفيرتيسيز وبروح ايه بعمل لي ليست. هذه الليست تمام. وبعدين ببتدي اعمل ايش اسوي؟ بوينتر. مثلا ال1 point to what? to 2 and 4. 2 and 4. This is pointer to 2, then from 2 to 4. Because there is a link between 2 and 4. في عندي edge من الاثنين إلى الأربعة. في الأول في عندي edge من الواحد إلى الاثنين، وبعدين عندي من الاثنين للأربعة. وهكذا باقي الإيش؟ باقي الإدجز. كلير ولا مش كلير؟ سهلة ولا صعبة؟ طيب simple directed labeled graph. This is the code. Class graph, private boolean, edges, private object labels. Those are the vertex. Those are the edges. تمام. طيب وهذا الإدج ميثود true. وهذا الليبل لازم نعطي اسماء للفيرتيسيز ونعطي اسماء للإدجز. طبعا الإدج تعرف بالسورس والديستنيشن. تعرف الدايركتد إدج بالسورس والديستنيشن. تمام. نيبرز ميثود، وهذا الكود تبع النيبرز، وهذا الكود مكمل اقرأوه. وهذا اذا كان في إدج بنحط ترو، اذا كان نو إدج فولس. وهذا بيحسب لك اللينث تبع الليبل. تمام. الاو نوتيشن او اوف ان. تمام. والاو نوتيشن اوف ذا ايدجز او اوف اي. ايوه هنا عندي الشيء المهم البريدث فيرست سيرش دي اف اس، والبريدث فيرست سيرش بي اف اس. دي اف اس وبي اف اس. هنبتدي بالدي اف اس. Use stack or recursion to start set of vertices to be visited. From a given vertex visit neighbors I plus 1 to n only after traversing all possible edges from neighboring I. هذا الكود او هذا البسيودو كود. تمام. وهذه الستبس. طيب الان انتبه معي. بدنا ناخذ مثال على الدي اف اس. هنشتغل على مين؟ على الستاك. هنشتغل على الستاك. عندي جراف وبدنا نشتغل على الستارت. هو بيقول لي ستارت فروم وير؟ فروم ايه. هنبتدي من الايه. تمام. اذا في عندي حاجتين ثنتين بدي احسبهم، الستاك فاليو والاوتبوت. الستاك فاليو والاوتبوت. هابتدي بالايه. بعد الايه مين حيجي بعد الايه؟ البي. بعد البي السي. بعد السي الدي. A B C D. بعد الدي مين؟ حنرجع من الدي، تمام، هتتحذف من الستاك. ايوه، هناخد مين؟ الجي. لا، الجي لسه قبل ما نوصل للجي، الجي هنا لسه. انا وين؟ عند الاي، فانا ايه بمشي بالتسلسل. تمام. اي بعد الاي، مين بعد الاي؟ الاف. تمام. مين بعد الاف يا مريم؟ الجي. الله ينكت عليكم. تمام. طبعا اذا حبيت ترجع حترجع بالمسار العكسي، حتتحذف الجي، بعدين حتتحذف الاف، بعدين الاي، بعدين السي، بعدين البي، بعدين الاي. هم مش حيتحذفوا، هم حيجوا هنا. تمام. هنا في اكزامبل ثاني هنخليه للمحاضرة القادمة ان شاء الله تعالى. اوكي. اذا في عندكم سؤال او استفسار تفضلوا يا اخوان. طيب، السلام عليكم ورحمة الله وبركاته.